So what is a Hopfield network? A Hopfield network is a pretty kind of old style, old conceptualization of a neural network. So in a Hopfield network, what your goal would be is, you can conceptualize it as a bit of a neural network. So let's say we have 5 neurons or something like this. What your goal would be is to have a neural network where you can store so-called patterns. And a pattern in this case would be a binary string of size 5. So for example, 10100 or 11010. And you'd have a list of these patterns. And what your goal would be is to store these patterns in the neural network such that, and here, we'll just consider everything to be sort of connected to everything else. And what your goal would be in this is that you can kind of store patterns inside this neural network, and you adjust the weights somehow. So this was, as I said, this is kind of an old model. You adapt the weights such that you store these patterns. And what does it mean for a pattern to be stored? If you have stored a pattern, you will then be able to retrieve it. And you retrieve a pattern in these kind of old style Hopfield networks by providing a partial pattern. So what you'll say is, for example, I want a pattern that starts with 110. And you give that to the network, and there would be a so-called update rule. And the update rule is kind of an internal rule. So let's just go through this. So here, this 110, maybe this is 110, and then they would kind of send messages around. So this update rule would somehow adjust the value of this and this neuron here to what's most compatible with the network weights. And if the network weights have been adjusted correctly, this will turn out then at the end of applying this update rule that this is a 1 and this is a 0, and therefore this pattern here is retrieved. Now, had I input 101 at the beginning, then the outcome would be different. Hopefully this pattern here would have been retrieved. Okay, so you can see the applications of this, like you can have the first 3 digits as sort of a database key, and then the last ones as sort of the value that you store along with it, and then you can simply provide the first few. You can also provide, you don't always have to provide 3. So this all depends. This is sort of as I said, an old conceptualization of neural networks. So people were imagining that this is kind of how the brain works, fire together, wire together. And also with research into this, it turns out that, you might think, there's kind of 5 neurons. So maybe I can store 5 different patterns, accurately. Because if I store too many patterns, right, if I have many patterns, then I can't expect to be able to retrieve all the patterns again, because some of them will just be so equal that, many will start maybe with this, and I won't have a chance to retrieve the one I want, or the update rule will make a mistake. So you might think this might be like 5 because I have 5 neurons, or maybe 10 because I have 10 connections, but it turns out that in modern Hopfield networks, with the appropriate update rule, you can store exponentially many patterns in these networks, exponentially many in the dimension of the patterns. And here, I guess that would be the length of the pattern. So this is a little bit surprising, the kind of storage capacity of these networks.